In this video, we will learn about the variation of atmospheric pressure with altitude. Now, we can consider the atmospheric pressure to consist of a number of parallel air layers set one over the other like this. Now, each layer experiences a pressure due to the weight of the air column above it. Okay, so suppose that this is the air column and this is the layer. So, each layer experiences a pressure due to the weight of the air column above it. Now, the atmospheric pressure is thus a function of height above the sea level, that is, the altitude of a given place. In fact, the atmospheric pressure goes on decreasing with altitude due to following two reasons. First is, as we go up and up from the Earth's surface, the height h of the air column above it goes on decreasing, right? So, as a result, the weight of the air column above it goes on decreasing, and the atmospheric pressure goes on decreasing with the increase in altitude. Suppose I am saying that at the most down level, that is near to the surface of the earth, all the air molecules above it are exerting a force. So this creates a pressure that is maximum in the first layer. Now as we go up, the air column weight decreases, so as the pressure also decreases with height or the altitude. Okay. Now, as lower layers of atmospheric air get compressed due to the weight of the air column above them, the density of the air layers near the Earth's surface is maximum, and it decreases with the increase in altitude. We know that pressure is equal to rho g h. Hence, we can see that the decrease in density also means a decrease in pressure, because pressure is directly proportional to density as well. Now, this figure simply depicts the variation or the graphical variation of atmospheric pressure with altitude. As you can see, as the altitude is increasing, we can conclude that atmospheric pressure is reduced to one half of its original value when the altitude increases only by 6 kilometers. So 6 kilometers above the level of Earth or the Earth's surface, the atmospheric pressure is reduced to half. If at Earth's surface the atmospheric pressure is 1 atm, then above 6 kilometers it would be 0.5 atm. Okay. Moreover, the variation of atmospheric pressure with altitude is not linear. Near the Earth's surface, atmospheric pressure decreases rapidly with increase in altitude. So, what are the consequences of variation of atmospheric pressure with altitude? So, there are few important things of variation of atmospheric pressure with the altitude, which are as follows. First is, atmospheric pressure is less at high altitudes. So, on high hills, breathing becomes more difficult, okay? Because we know for a fact that breathing depends upon the external pressure and internal pressure. When the internal pressure in a lung is less than the external pressure, then air enters our lung. But at hilly areas or high altitudes, the external pressure is also less. So we find difficult to breathe at high altitudes. Persons suffering with high blood pressure or asthma may feel breathlessness at higher altitudes due to this particular reason. Secondly, we know that our blood pressure balances the atmospheric pressure acting on our body. So, at high altitudes, as the pressure is low, due to the decrease in atmospheric pressure, the equilibrium is disturbed, and this imbalance may also cause nose bleeding. Third is, a fountain pen often leaks at high altitudes because in a fountain pen, the ink is held against the atmospheric pressure. At higher altitudes, the atmospheric pressure is less, so that the excess pressure inside the rubber tube of the fountain pen may force the ink to leak out. Okay, I hope this topic is clear to you. Thank you.